This video is about the first derivative and its graphs. Let's do some warm-up. Find the intervals on which it's increasing, decreasing, or constant. Increasing means the graph from left side to the right side going up. Decreasing means from left side to right side, the graph going down. Constant will be horizontal. Therefore, first of all, increasing, let's find the increasing graph. This is increasing graph. Increasing graph. And this is an increasing graph. Therefore, the increasing intervals, that means we're looking for domain. When you talk about interval means domain. The first interval, that is from -8 to -2. Union set. This is the second interval, 0 to 2. Union set from 5 to infinity. For decreasing intervals, the graph going down from left to right. This is down. And this interval is down. So for first interval, that is from -infinity to -8. Union set, -2 to 0. And a union set from 2 to 5. No constant interval for this graph. Second question, find the intervals on which f of x greater than 0 or f of x less than 0. The function greater than 0, that means above x-axis. Less than 0 means below x-axis. Therefore, first of all, you will draw all the graph above x-axis. It's here. And also here. But remember, the x-intercept will be excluded. Therefore, we can write down fx greater than 0. You will have 1, 2, 3, 4 intervals. We will write down from -infinity to -10. Remember, it's open parentheses because it said greater than 0, not greater than equal to 0. From -5 to 0. From 0 to 5. From 5 to infinity. For f of x less than 0, we need the graph below x-axis from here to here. Therefore, we only have one interval to write, -10 to -5. Let's go to number 3. Find the x-intercept of the function. 1, 2, 3, 4. So we write down the coordinate, -10, 0, -5, 0. 0, 0, and 5, 0. For number 4, find the local maximum and a local minimum if there's any. This is a minimum, maximum, minimum. Maximum. Here's a minimum. Therefore, you can write down that is for minimum. -8, -4, 0, 0. For maximum, you will have -2, 6, and 2, 10. First of all, let's go over the meaning of the first derivative of fx. As we know, the first derivative of fx is the instantaneous rate of change of a function at a point. From this graph, we know this is a tangent line. The slope of a tangent line equals the first derivative of fx. We also can use this limit to show the first derivative. In other words, we can interpret the first derivative as the slope of a tangent line to the curve at x. The derivative at the local maximum and minimum point that's equals to 0. For example, this point is a maximum and this point is minimum. Let's label as x1 and x2. Then we have the first derivative of f of x1 equal to 0. And also the first derivative of f of x2 equal to 0. Because check their tangent line is a horizontal tangent line, the slope will be equal to 0. We already know that first derivative means the slope of a tangent line, where the first derivative equal to 0, which means where we can have a horizontal line as a tangent line. It will be at local maximum, local minimum, or stationary inflection. For the local maximum value, you see I can draw the tangent line, that's horizontal line. And make sure we have a sign diagram. At A, there is a sign change from positive to negative for local maximum. For local minimum, let's draw a tangent line. You could say this is a horizontal line, means slope equal to 0. And first the derivative of fx has a sign change from negative to positive at A. For stationary inflection, we know that the first derivative of f of A equal to 0, and also the second derivative of A equal to 0 too. Then for the first derivative, there's no sign change at A. Let's talk about the first derivative f of x and its graph. F of x is increasing on S like this 3 graph. Then we can draw a conclusion that the derivative of f of x will be positive or greater than or equal to 0. Because when you draw the tangent line for this graph, you could say the slope for all this tangent line is positive. In other words, the first derivative means the slope of tangent line will be positive. For the following graph, f of x is decreasing. When you sketch the tangent line, you could see the first derivative of f of x, which means the slope of this tangent line is negative. So we can see the first derivative of fx less than 0. Since we know the meaning of derivative, the positive first derivative means increasing interval. Therefore, for this part means the first derivative of f of x greater than 0. Decreasing interval means the first derivative of fx less than 0. And at minimum or maximum point, the first derivative equals 0. Now let's go to guided practice 1. Find the intervals on which the first derivative greater than 0, the first derivative less than 0, or the first derivative equal to 0. We know that the first derivative greater than 0 means increasing graph. First derivative less than 0 means decreasing graph. For first derivative equal to 0, either you have maximum, minimum, or stationary inflection. Therefore, for first derivative greater than 0, we're looking for the increasing interval. This one, or this one, is an increasing graph. So we have from negative infinity to negative 2. And from 1 to positive infinity. For first derivative less than 0, you will see this is a decreasing interval from negative 2 to 1. For first derivative equal to 0, we have a maximum point, minimum point, and this point is a stationary inflection. So we can write down first derivative of f of negative 2 equals 0. First derivative of f of 1 equal to 0. First derivative of f of 3 equal to 0.